In this lecture, we talk about implementation of stacks and queues using linked lists. In the previous lecture, we have seen the implementation of stacks and queues using arrays. In this implementation, in case of stacks, the last in first out scenario can be implemented by inserting or deleting a node from the head. So if we want to add a new node or if we want to push data into the stack, we will create a new node and we'll add it to the existing head. So if we want to push data, we need to create a node here in this case, and the temp is equal to new, create node. We create a temporary node, and data is kept in the temp. So data of temp is equal to data to be inserted, and next of temp is equal to top. So whatever new node is created, that has to be appended at the head node. So whatever existing head is, top is an existing head. So next of temp is equal to top, a link is created, and top is adjusted to the new node. So top is equal to temp. This is how we'll push the data into the stack. Similarly, when it comes to the deletion or pop operation in the stack, we need to check whether the stack is empty or not. Stack is empty provided top is equal to null. So if top is equal to null, print stack is empty. Else, whatever top node is there, head node is there, that has to be removed. So top is taken to temp, and top is adjusted to next of top. So top is lowered down by 1. So top is equal to next of top, and delete top. Whatever current top is there, that is to be deleted. So that the top node is deleted. That is pop operation in case of linked stacks. This is how we can implement stacks using linked lists. The advantage of stack implementation using linked lists is we can dynamically grow or shrink the stack at our convenience. When it comes to the implementation of queue using linked lists, the first in first out has to be implemented here. So whenever a new node is added, that is to be added at the end part of the linked list, rear part. Similarly, whenever a node is deleted, that has to be deleted from the front part, head part. So if you want to insert data into the queue, so we take input as head, the existing linked list, whatever is there in the form of a queue, that is taken as input, and data to be inserted. So temp is equal to head. We need to traverse through the linked list until we reach the last node so that we can add the new value, new node at the end. So while next of temp not equal to null, temp is equal to next of temp, we keep on moving into the last node. Temp 1 is equal to create node. Once we reach the last node, a new node is created. Temp 1 is equal to create node, and data of temp 1 is equal to data. Data is inserted into the new node, and the next of temp is equal to temp 1. So link is created at the end so that any new node is added at the end. Similarly, when it comes to the deletion, whatever current head is there, that has to be deleted. The front node has to be deleted. So we implemented delete head. For this, temp is taken to head is taken to temp, and head is updated as next of head. Whatever current head is there, that is updated as next of head, and temp is deleted. So this is how we implement queues using linked lists. Again, the advantage is that we can have dynamically increase the linked queues to any length dynamically. One of the interesting features of mixing the data structures and creating a combination of data structures can also be done here. One such combination is array of linked lists. If you have a collection of linked lists and all these linked lists can be accessed one after the other or in any order through an array. So once we create a linked list, the head node is taken, head value is taken and it is stored in the form of an array value. So if we create an array consisting of all heads of the linked lists, we can directly access any linked list, and a collection of linked lists can be maintained in the form of an array. So this can be seen as array of linked lists. Similarly, this can also be done through a linked list. A linked list of linked lists can be created so that we can dynamically adjust any size of the linked list, and we can dynamically adjust the collection of linked lists also. So head value consists of the the link to the linked list, and link of the node points to the next value of the linked list. So this is how we can keep on linking the linked list in the form of a linked list of linked lists.